This video covers some history behind the notation used for functional programming. As some of you know, the programming language Eiffel uses the keyword agent to denote a feature without a name. For example, the code that you see on the screen defines an object representing a function x plus x without giving it a name. Why functions without a name are so important? Before answering this question, let's look at what mathematicians do. For the function above, they write lambda x dot x plus x, sometimes without the dot before the expression. Initially, every function had its name: plus for addition, minus for negation, square, square root, sine, logarithm, and so on. Mathematicians quickly realized that the number of functions is infinite. Therefore, they invented a special notation using the symbol lambda. According to Peter Norvig, the author of the book Paradigms of Artificial Intelligence Programming, the name lambda comes from the mathematician Alonzo Church's notation for functions. In the second decade of the 20th century, Alfred North Whitehead and Bertrand Russell published a book, Principia Mathematica, which used a caret over bound variables. By the way, in LaTeX, the well-known publishing system, the caret symbol is also known as a hat, and the formula above is written as hat of x, x plus x. Let's come back to the history. Quote: Church wanted a one-dimensional string, so he moved the caret in front. The caret looked funny with nothing below it, so Church switched to the closest thing, an uppercase lambda. The uppercase lambda was easily confused with other symbols, so eventually the lowercase lambda was substituted. John McCarthy was a student of Church's at Princeton, so when McCarthy invented Lisp in 1958, he adopted the lambda notation. There were no Greek letters on the key punches of that era, so McCarthy used lambda, and it has survived to this day. End quote. We see that the programming language Lisp used the name lambda to denote functions without names just because there were no Greek letters in programs at those days. Clearly, the restriction to use only ASCII letters does not apply to Eiffel. So, why else does Eiffel use agent instead? Well, first of all, it's one letter shorter. But we can do better. With introduction of Unicode, it became possible to have just one special symbol, similar to the original secret symbol used in the Principia Mathematica. To summarize, like Alonzo Church, we want this symbol to be on the same line, be special, and have a hat. Recall the LaTeX notation mentioned earlier. As some of you could have guessed, the obvious candidate is a special agent, the agent 007. The Unicode defines the corresponding symbol as 1F575, possibly followed by an optional variation selector, one for text and one for emoji. By the way, the roots go even deeper. Principia Mathematica was published in 1910, and in the film Dr. No, James Bond uses a Belgian pistol FN model 1910. The connection is obvious. Now we have come to the final part of the story. How does one type this Unicode symbol in AFIL Studio without going crazy? The most recent version of the development environment, autocompletion recognizes names of commonly used Unicode symbols. Let's see how it works in the example I have prepared. The system has a root class agent 007 with the root creation procedure operate. This procedure calls two features, recruit and use. The feature recruit initializes the attribute location with the secret procedure. This is a simplified variant of the agent example we saw at the beginning of the video. But now, not only without a name, but also without arguments. It was built from the feature print and the location name. The feature use reports the previously stipulated location. If I run the program, it prints the expected message with the secret location name. Let's come back to the source code. When I press Ctrl space after the keyword agent, the completion list contains the agent symbol. I select the symbol and press Enter. The same technique works for other names as well. For example, I can replace print with a single icon. I compile the program and run it. The program works as before. Let's change the location name, compile and run it again. The output of the program reflects the changes as expected. As you can see in the title of AFIL Studio window, the functionality is available in 1904. By the way, the convention used to specify the version number suffers from the Y21H problem, similar to the Y2K problem experienced at the beginning of the 21st century, when it was unclear if the number 00 stands for 1900 or 2000. Nowadays, two-digit version number does not distinguish between 2000 and 2100. Therefore, to avoid version number overflow, all digits are now supplied. Somebody familiar with previous releases may ask, where is the build number? And indeed, the full version number is 20, 19, 04, 01, 06, 25, 43. You can find the complete specification of the version format in the ISO standard 8601. That's all for now. In the next video, I'm going to discuss what are the best practices in using emoji color in your programs. Talk to you soon.